Hello. In this talk, we're going to challenge some long-held assumptions, and at the very end, we're going to have a banger video. Okay, so the first claim is that we obviously have world computing technology. That's why we're all here. Some people think that the world computer is just an open financial system where you can program money. For them, things are great. But this crowd is open to the idea that actually the world computer is for worlds. And this isn't obvious yet. And we think it's because while we have the tech, we don't have the design for a world computer. I think we have actually just designed it like a personal computer, which is meant to be a tool for a person to control. It's not a computer that's meant to host some emergent world. And because of that, we're missing out on a totally different future where it's actually clear that the world computer is for worlds. Fundamentally, a personal computer is based on account permissions. The owner of the computer decides which accounts can take which actions. And this is deeply ingrained in how we think of computers today, so much so that we don't even challenge it. When it comes to the world computer, we have replaced the owner with the smart contract, but it's still the same paradigm of account permissions. Now a smart contract decides which accounts can take which actions. And the way it does this is via own-to-act. The smart contract allows an account that owns a specific key pair or NFT or token to perform the action. Of course, we can program all sorts of fancy mechanisms for NFT gating or token voting, but ultimately it boils down to the idea that accounts need to own to act. And this is the core problem. We still use account permissions, even though that paradigm was created for personal computing. So we're stuck with own to act apps. But having special permissions for special people goes against the point that this is supposed to be a computer equally shared by everyone. Ultimately, it kills emergence, and worlds require emergence. So we claim that we don't actually have world computing design. We have this frame of what we think a computer is, a tool for a person to control that does what we program it to do. This frame is all we have really ever been used to. So it's no surprise that the frame carried over when we set out to build the world computer. But the world computer isn't meant to be a tool for people to control. It's supposed to be an emergent, it's supposed to be a computer that hosts an emergent world. This is a fundamental paradigm shift in the way computers might play a role in our lives. So it likely requires a fundamental design shift in how we actually create these world computers. So to actually create a world computer, we need to think a bit different again. We need to step back and go look at a totally different kind of computer. Our universe's computer. It's not controlled by anyone. That's why it can host such an emergent world. Physics decides who can do what, not permissions for special people. And taking inspiration from it to think about how to start designing radically different computers, ones that are for worlds rather than for people, is a good start. We're going to show how to do this. We're going to talk about Zeus, which is a new type of computer we have been working on, one which uses the tenets of physics rather than accounts to decide who can do what. To get this emergent world, which still maintains order without any special owners that have special permissions, we need to design our computers to emulate the tenets of physics. Add things like the notion of space, locality, causality. So let's start with space. EVM represents space as a list of addresses. On Zeus, space is represented with XYZ coordinates. On the EVM, every single address is an account which has a balance. On Zeus, each position has an object that has energy. On the EVM, accounts can only interact with accounts can interact with any other account. You can transfer a balance, to any account. It doesn't matter. On Zeus, an object can only interact with its surroundings. On the EVM, accounts interact with each other by calling them. A smart contract calls another smart contract, and they both update. On Zeus, objects don't call each other. I can't call that chair and tell it to move. Instead, objects interact by reacting to each other. An object changes its state, and its surroundings will react by changing too, and this propagates. So at this point, we have an empty spatial computer. There are no objects in it. We want there to be objects. But what you want is permissionless creativity. You want anyone to add these objects. But the new objects must follow rules and past constraints. This makes sure that we can all help shape the world, what it looks like, without one bad actor being able to ruin it for the rest of us. So what we can do is we can have code, right? Just like an account on the EVM can have code and storage, we call this a smart contract. An object on Zeus can also have code and storage. But it's not the same type of code because this runs on a very different kind of computer, a computer for physics. An object's code can read the state of its surroundings to update itself. After that, surrounding objects will react and do the same thing. This will propagate until there are no further changes. This is very similar to how sort of our world works. Now, the object's code can't be arbitrary. If we think of the EVM, code on the EVM follows rules and passes constraints. On the EVM, all code must follow a rule that a transaction fee is spent whenever it executes, and it must pass a constraint that it can only transfer an amount lower than its balance. Any Zeus instance will have to define the rules and constraints that must be followed by the objects allowed in that world. We've been working on one ourselves, so our rules and constraints look like this energy cycle. Once the world sets rules on allowed objects, anyone can create objects that abide by those rules. So people can invent various types of soils and agents and blocks. The world computer starts with empty space, but anyone can deploy those created objects into that space. So now we have a computer that is filled with objects, but when does it update state? Well, on the EVM, state changes are initiated by accounts which are externally owned. On Zeus, state changes are initiated by objects which are externally controlled. For example, an externally controlled object can move itself, subject to momentum costs. It can move its surroundings. It can trigger reactions in its surroundings. All of these things will cause the object surroundings to react and update. So now we have a physics computer filled with objects created by anyone, and people use externally controlled objects to cause it to update. And on top of this, a ton of stories can emerge. They would all rely on the physics, but wouldn't be enforced by it. You can think of it like we have this universe, and all of us have stories which sort of run in our head and dictate our actions. But the universe computer doesn't care about them. It only cares about the physics. So to make it really concrete, what we have is a Zeus computer, right, which is based on physics, and then we have a regular EVM computer. On the EVM computer, you can deploy smart contracts that can program all sorts of stories and social systems based on what it reads from the Zeus world. Of course, nothing in those smart contracts can be enforced by Zeus itself, since these are two separate, different computers. For example, a smart contract could say that you own some land on the Zeus computer, but Zeus has no idea, so someone could totally come use your land. As a result, the smart contract would also need to think about incentives to prevent that. Let's make it really concrete. So on Zeus computer, let's say you have a really small interaction where creatures are fighting and farmers are growing food. The EVM computer can read it, right? So there could be a smart contract which reads the creature fights, and it sort of generates a leaderboard based on wins and losses. And you could have another smart contract where farmers claim some land to grow food and give permission to a specific type of creature to eat from their farm. However, this is just a story. Zeus physics doesn't care about it. So another type of creature that doesn't have permission to eat from that farm could still totally go and eat from there. And at that point, our smart contract would need additional mechanisms. Like if a creature eats from a farm they're not allowed to, you can report them and they get disqualified from the leaderboard, put on a criminals list, maybe a bounty is attached to go catch them. It's similar to our universe where social systems can always be broken, and you have social coordination like the military to prevent them from being broken. It leads to more emergence. So we now have a new kind of world computer, which is based on physics. World designers craft rules and constraints for what objects are allowed in that world, and then they deploy it. After that, nobody has control over what happens in the world. Anyone can come along and create and deploy all sorts of objects to that world. And anyone can write regular smart contracts on a separate EVM computer that can read from a physics computer to program stories. So now we have a video So that was our presentation. You can visit tenet.aw. It's live right now. You'll be able to learn about Zeus, which is the spatial computer. It's a new kind of world computer. And you'll be able to explore Everlon, the virtual world video we just played. We'd like to thank our sponsors and funders, AW House, Builders Guild, and Xerox PARC. And we leave you with a post-assembly question. If GUIs were what took computing from industrial to personal, what will it be that will take Ethereum from hosting finance to hosting worlds? We hope you enjoyed the presentation. See you at the post-assembly. And we have a workshop tomorrow. So you guys should come there and you'll see everything in much more detail. Thanks.